Okay, number 1 asks which figure is a convex polygon. So there's really 2 words at play here. The first is polygon, and polygon is a shape with all straight edges that's closed. So if we think about the 4 shapes here, the ones that are polygons are C and D. These first 2 are not because they have some curved edges. And then convex means that it's not caved in at all. And you can see, well, this one would be convex. B would not be convex. The triangle here is convex. And this other last one is not convex because it buckles in right there. So you can see the only one that's both convex and a polygon is B. I mean C. It is the 3rd one. It looks like my printout here is messed up. So this is actually C. Number 2, we have an isosceles triangle with a perimeter of 40 and a base of 12. So if I'm going to go ahead and draw the isosceles triangle, that bottom part's the base. We have 2 congruent legs. That makes it isosceles. We know the base here is 12. The perimeter, which is all the way around, is 40. So I'm going to call each one of these sides x. And we know they're the same because it's isosceles. So we set that up. We have x plus 12 go all the way around the triangle is going to equal 40. And then we can combine the x's here. Subtract 12 from both sides to get 2x equals 28. X equals 14. That's the measure of one of the legs. Number 3, we need to classify this triangle, but we have some unknown sides. But we do know up here that the perimeter is 32. So we'll go ahead and add up the 3 sides. 10 plus x plus 7 plus 2x minus 3. We know that equals 32. And then we'll just collect some terms here. We have 10 plus 7 minus 3. And then we have x and 2x, so combine those. 3x equals 32. 10 plus 7, 17, minus 3 is 14, plus 3x equals 32. Subtract 14 from both sides to get 3x equals 18, x equals 6. And we can go ahead and substitute the sides in here. 10 stays the same. X plus 7 here, up here at GF is going to be 13. 2x minus 3 is 2 times 6 minus 3. That's 12 minus 3 is 9. So we can see the sides here are 10, 13, and 9. They're all different, which gives us the answer of scalene. Number 4, this is a straightforward application of the exterior angle for a triangle. One quick thing to remember here would just be that this angle equals the sum of these 2. So the fast answer would be x equals 70 plus 80, 150. Or if you want to reason through this, we know that the 3 angles of a triangle have to add up to 180. If these 2 here add up to 70, we know that this angle has to be 30. And then 30 and x form a linear pair, or supplements. So we could just find x here by taking 180 minus 30, which also gives us 150 degrees. Here we're given a triangle has angle measures of 2x plus 8, 3x plus 5, 6x plus 2. What's the measure of each angle? If we go ahead and draw this triangle here, we know one angle is 2x plus 8, the other one is 3x plus 5, and the other one is 6x plus 2. The sum of all the angles in a triangle equal 180. So we can just add those up. Then we'll combine like terms. We have a 2x, a 3x, and a 6x is 11x. 8 plus 5 plus 2 is 15, equals 180. Then we subtract 15 to both sides to get 11x equals 165, which means x equals 15. And then we just have to, it wants to each measure of each angle, so we have to substitute x equals 15 back into these 3 up here. So I've done that substitution here for the 3 different angles, and we get the 3 angles of 38, 50, and 92, and it is in order of smallest to largest. Okay, 6, what is true about all right triangles? Let's go ahead and just draw one here just to have something to work with as we evaluate them. Side A, two sides are congruent. Well, not necessarily true. You know, we could have a 3, 4, 5 triangle. That one's not, and that would be a right triangle, but not with two congruent sides. They have two acute angles. Well, because this one is 90, each one of these, the sum of this one and this one has to add up to 90. So if we have, I'll call this one of them x and one y, so x plus y equals 90. Because one of these angles can't be 0, that means that for two numbers to add up to 90, they each need to be less than 90 if one of them can't be 0. And so that's the definition of acute. So it is going to be B. And obviously you can't have a second right angle, because if you had two 90s, that would add up to 180, and the third angle would have to be 0. So it's not going to be D. And for the same reason, they can't have one obtuse angle. If one of them is 90, the other two add up to 90. So obtuse means greater than 90. And so that one can't be right either. The answer is B. Here's another exterior angle problem for a triangle. The first most straightforward one is that the exterior angle of a triangle, which is y degrees here, equals the sum of the two, I guess you call them opposite angles. So that would be the first approach here, is to say that y degrees, which is the exterior, equals the sum of the other ones, the other two across from it, y minus 30 plus y minus 80. And that gives us y equals 2y minus 110. We'll move the 110 to this side and this y to that side. So we get 110 equals y, and that is the answer. Well, the polygon angle sum theorem, well, this, I suppose, is just a formula memorization question. So that's D, where, you know, for like a 10-sided, if we had a 10-sided polygon, the sum of the angles inside it would be, 8 times 180, for example. I thought maybe I'd just spend a quick minute here trying to justify why that is. So let's just kind of see a pattern here. If I take, say, a quadrilateral, four-sided, and I divide it into triangles, what we care about here is the sum of this angle, this angle, this angle, this angle, this angle. We can see we can find those by adding the angles up inside the triangle. So if we had this angle, this angle, this angle, this angle, this angle, and this angle, we'll get the sum of all the angles. Well, if we have two triangles, we know that each one of them has to add up to 180. So in this case, we could take 180 times 2. If we had a pentagon, again, we just pick a vertex, make some triangles. If we want to figure out the sum of all the interior angles, we could just look at the triangles, and I'm just dotting them all here, what we'd add up. So it's basically adding up all the angles inside that triangle. And so here we have 3 triangles, all with the 180. So you get 180 times 3. And we'll just do one last one here, the hexagon. Pick a vertex, draw on all the triangles. And here we can see it splits it into 4 triangles, where we add up all these 180s to get the sum of the interior angles. 180 times 4. The number of sides here is 4, the number of sides here is 5, the number of sides here is 6. So hopefully you can see the pattern here that for any n-gon, we're going to get 180 times the number of sides minus 2. Here this looks almost identical, but now it wants the measure of the exterior angles of an n-gon. I'm going to draw, we'll just draw a pentagon so we know what the exterior angles even mean. What this is saying is, let's take a look at this angle, which I'll label 1, this angle, which I'll label 2, this angle that I'll label 3, this angle that I'll label 4. And so the question is, what is angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 equal? Well, it turns out that for any polygon, the sum of those exterior angles always equals 360 degrees. I can't really show it now, but I have a nice visual demo of this that I could share with you if anyone is interested. But for now, let's just remember that that's going to be 360 for any polygon whose sides all have the same length is said to be, well, same is going to mean equa, so we can probably going to be one of those, and it's not equal angular because we care about the sides. It will be, in fact, equilateral, which the roots of those words there mean equal sides. Well, we know it's not convex. Some people might wonder, well, why isn't it regular? Regular actually means both B and C. So in order to be a regular polygon, you need to have equal sides and equal angles. So here we have a quadrilateral and we need to find this missing angle. Well, this quadrilateral has 4 sides, and we know that these are all interior angles shown. So we know that the sum of the interior angles is going to be 180 times n minus 2, so 4 minus 2, or 360. Now many people just choose to remember that any quadrilateral, all the angles inside all add up to 360, but this is where it comes from. It's, for that same formula there. So here we just have to add up these angles. We know that 80 plus 120 plus 70 plus x equals 360. And here I've just done the algebra, collect the terms, and you solve this to get x equals 90. Sum of the interior angles of a pentagon. We know pentagon has 5 sides, and we just talked about this in the prior problems, that the sum of the angles of the interior angles is going to be 180 times n minus 2. Remember, it's like dividing it into triangles. 180 times 3 is going to be 540 degrees. Here, find the measure of each interior angle of a regular 15-sided polygon. So first we have to, here we want each angle, but the first part of this is to find the sum, which we're getting good at now. 180 degrees times, this is n of 15 minus 3. So we know the sum of all those angles inside that 15-sided polygon is 2,340. Now if we want each interior angle, we just take the sum and divide it by 15 to get 156 degrees. Here we want the measure of each exterior angle. I'm not drawing the whole thing here, but just remind ourselves that if this is part of the nonagon here, wow, that's a really bad drawing. This right here is the exterior angle, and we want to see what one of those is. Again, we're going to use the sum approach. The sum of the exterior angles of a polygon always equals 360. Since a nonagon has 9 sides, 360 divided by 9 is going to give us 40 degrees for each one of those exterior angles. Kind of like the go backwards version of the prior problem. Here, if this is a part of our polygon here, we know every exterior angle here equals 45 degrees. Well, we know that they all have to add up to 360. But we don't know how many sides there are, so I'm going to call that n is the number of sides. So 45 degrees times n has to be 360, and then we can just solve this proportion for n. 360 divided by 45 gives us 8, and we know that 8 sides, hopefully, is an octagon. Now here, this is the interior angle version of the prior problem. If we have some sort of partial polygon here, we know that each one of these angles is 120 degrees. And we know that the sum of the angles is 180 times n minus 2, which means that each angle will be the sum divided by n, and again, we don't know what n is here. We're trying to find it, so that's why I'm using a variable n. So 180 times n minus 2 all over n. But we are given that each angle is 120, so we can go ahead and set that equal here, equals 120. And then we can go ahead and solve this equation here. I'm just going to cross multiply by n here, so we get 180 n minus 2 equals 120 n. I'm going to distribute the 180 here, 180 n minus 360. Don't forget to distribute that, keep that minus sign there, equals 120 n. Subtract 120 n from both sides here. We get 60 n on the left. 360 is going to go to this side. 360, 60 n, n equals 360 over 60, which gives us 6. And 6 sides is a hexagon.